Hello everyone. We will start the webinar in a couple of minutes when everyone's had a chance to arrive. It'll feature a recording of webinar delivered earlier today, and then we will be available for live questions at the end of it in about 35 minutes time. So please do submit your question in the chat pod below. Thank you. Good morning, everyone, or good afternoon, wherever you are. Thank you very much for joining the latest emissions analytics webinar. Today, we're focusing on tyre emissions and specifically how we go about the analytical testing of tyres with a focus on 6ppd and its alternatives. Clearly a topic in the news, one that's growing around the world, but really as a sort of leading question as to what other compounds of concern there might be in tyres. Today we will be speaking for about half an hour or so, leaving another half an hour for your questions. So please do submit them in the chat box. We'll try and cover them all. I'm also very pleased to have with me is Dr. Yusuf, who is our applications chemist and has led much of this testing work. And he will be covering some of the slides regarding the method that we use to perform the analytical analysis. And it will be available at the end as well to take questions too. I'm going to, if everyone can hear us okay, I'm going to dive straight in. There will be the slides available for attendees afterwards. It won't be circulated automatically, but if you would like to receive them, then please do send us a message by email afterwards. So what I wanted to cover today is we will do a bit of a background piece on tyre emissions and 6ppd, but I'm not going to dwell on that too long because I suspect that many of the people on this call will already be very familiar with that as the problem. But I do want to just briefly cover it for those who might not be familiar. Then moving on to how we're understanding the impacts on the environment, what the emerging regulations are in US and Europe, but then crucially, what is our experimental approach and what results on 6ppd and its alternatives is that testing yielding? And finally, to finish up with what other compounds are we seeing in tyres and some further insights. So just briefly on us to set the scene, who are we and why are we tackling this topic? Our abiding concern as a company and why I set up emissions analytics in the first place was to study the holistic environmental impact of vehicles on the environment. We started with tailpipe, but actually however tyres impact the environment is what we're interested in, and we work independently with everyone up and down the supply chain in the whole ecosystem, from academic researchers through to industry and authorities. And if I had to encapsulate it in one idea, is we are trying to reconcile transportation with a sustainable environment. the answer isn't to ban all cars. The answer is to make transportation consistent with good environmental standards. And that's why we're focusing on tyre emissions. It's rising fast up the agenda. We've already conducted a large volume of tests, and we want to share those with you. And crucially as well, we'd like to engage with all of you. This is a challenging topic, and finding effective solutions, both addressing the problem at source, but also mitigating the effects in the environment, is of a pressing need, and we'd like to work with any of you to help forward that cause. So the issue, tyre emissions itself, what are they? Actually, it's a very loose and broad term which takes in everything from the manufacture of tyres, the materials going into it. There's a lot of talk about sustainable tyres. That's talking about substitute materials instead of fossil fuels going into the manufacture. Possibly the one that is most often referred to is the in-use phase, so the particles that are released during the use of tyres, but also the off-gassing of VOCs from the surface of tyres. And then the last one, which again forms a whole industry and area to itself, is the end-of-life processing of tyres. There's a vast number of tyres worldwide that come to the end of their life, and what do we do with them? How can we safely dispose of them on the one hand, but also put them to good use as well? The focus of this webinar is going to be primarily on the first two and not the recycling. Tyre emissions are, I think, by pretty much any calculation now, achieving a level of omnipresence in the world as a result of about 6 million tons of tyre wear globally being deposited into the environment. And that is just the wear material. That is not the end-of-life tyres, which roughly equates to somewhere between 1 and 4 kilograms of wear material per car per year. An average car probably is in the lower end of that range, but up to bigger trucks, it can be as much as 4 kilos per year, driving in a normal fashion. That excludes the 1 to 2 billion end-of-life tyres as well per year, which are a problem unto themselves. If we multiply what we're seeing by way of concentrations of 6 ppd in that tyre material, and that is setting aside the degradation processes that go on, if we simply multiply the concentrations we see in an average tyre by that amount of material, we're talking about 7,000 tons of 6 ppd, which is released per year globally. And I guess the litmus test of why it's omnipresent is that a recent study in China suggested that the concentration of 6 ppd and 6 ppd quinone in human urine was averaging about 135 nanograms per day per adult being passed. So it is getting into the environment and into us and out again, and that's why on a first pass it is a substantial issue. What's triggered this and what is 6 ppd? 6 ppd is a preservative added to tyres during the making of tyres. It has many facets to it, not least anti-ozonant and antioxidant, essentially to preserve the tyre, to prevent cracking and degradation. The issue is that it reacts to create 6 ppd quinone, which is a toxic compound, which was linked to the mass die-off of coho salmon in Oregon in 2020, which I'm sure pretty much all of you are familiar with, but it stands restating. And from our testing, we can say with confidence that every single tyre that we've tested in Europe and the US at the moment does contain 6 ppd. The vectors with which this the rubber material and therefore the 6 ppd affects humans can be summarized in this schematic. So you've got essentially particle mass, larger particles coming off, finer particles, better measured by particle number, but also VOCs off-gassing from the surface of tyres. And then they have multiple chains, directly and indirectly, that can affect humans, from direct inhalation through to secondary aerosol formation, which then get inhaled, but also these particles land on the soil and get into the food chain, get washed into water systems, and then into the sea and into the food chain, and even within the body, if you inhale these particles, leachate can then happen within the body. So it's complicated. It tends to be the parts of the vectors towards the bottom there marked is the vector for 6ppd to potentially affect humans. This whole topic, if the mass die-off of the coho salmon wasn't enough, the thing which is also spicing the topic is the role of electric vehicles, but also heavy vehicles more generally, and the declining emissions from tailpipes. We found on various experiments essentially that a typical electric vehicle is about 25 to 30% heavier than the equivalent internal combustion engine, and it leads to about 21% additional mass in terms of the wear rates. So, but that could equally apply to a very heavy pickup truck as well compared to a standard vehicle. At the same time, there is now virtually no particle mass coming out of the tailpipe, and so we're talking about 3 orders of magnitude more mass coming off tyres in typical operation than out of the exhaust pipe. So that's why it's an issue. So the regulatory intervention that's happening, and it's quite different between US and Europe. US California has been first to react with a 6ppd rule introduced in 2023 to address the coho salmon die-off issue. More details can be found at that link for those who are interested. Essentially, it's a rule that forces tyre manufacturers to look for alternatives and review alternatives to 6ppd or remove their tyres from sale. This has been addressed, I think, in regulatory terms very expeditiously, and it kicked off late last year. It's a multi-stage process, or there's multi-stages within the process, but once the process is complete, it is only a one-off process, which in our view may need to be repeated again in the future if no alternative is found in the short run. There is other action, similar but different, that's coming from other West Coast states as well. In terms of the very latest progress on this, to help push this forward, the US Tyre Manufacturers Association brought together 32 of the tyre manufacturing companies in a consortium which identified 60 potential alternatives as initial candidates. That has been whittled down to 7 that have been selected for further research. And as of August this year, the California EPA, the Department for Toxic Substances Control, got approved this consortium to move to the next stage of the alternatives analysis, which needs to report by August 2026 with a midpoint August next year. And to quote the industry's websites, they are optimistic that they will find a way to replace or materially reduce 6ppd. Now, I've underlined the or materially reduce there for good reason, because our testing, in short, suggests at the moment that there is no obvious direct substitute for 6ppd, but it would still be significantly beneficial and possible to reduce the amount of 6ppd in tyres without compromising their performance. To contrast, in Europe, the tyres are primarily being tackled through the new Euro 7 regulation, which will put a limit value on the distance-specific mass emissions, and so effectively to reduce the underlying wear rate itself. It's a little vague at the moment how that will apply to replacement tyres, which is a crucial part of this, and we're hoping for more details on that. The methodology is reasonably well advanced, being developed at UNECE for likely introduction later this decade. The challenge with this is that Euro 7 is blind to the chemical composition of tyres. That is dealt with in Europe through the REACH chemical regulation, which limits what can be put into tyres, but it only covers 8 polycyclic aromatic hydrocarbons commonly found in tyres at the moment. So one option would be for Europe to put a lot more chemical compounds in REACH to cover off that dimension as well. So that's enough, a very brief history of 6ppd and what's happening from a regulatory point of view. Moving on now to what we do in our experimental approach. And I'll shortly hand over to Ime to talk in more detail. But the way we approach it, so the first thing we're able to do is collect wear material in real world driving. So we've developed a patent pending system which has universal fitment on any vehicle that allows for collection of material in a road legal way on the public highway. And this collection mechanism can then be attached to any detector. So in principle, mass, number, and size distribution can be analysed, but also physically collecting the material. There is, of course, the limitation that you will pick up some non-tyre material as well, which we typically will separate after the test using chemical fingerprinting. So Ime, if I may pass over to you, if you can tell us a bit more about exactly how we go about this testing, please.
Thank you, Nick. Good morning, everyone. I hope you can hear me. So once we've collected the sample, like Nick has said in the previous slide, it comes back to me in the lab where we do the analysis. And in the analysis part, we use a two-dimensional GC mass spectrometry. Now you ask the question, why 2D? Why 2D? What is this really about 2D GC? 2D GC is a kind of GC where we use two different columns. So based on polarity to separate the compounds. So we are able to see more. In a standard one-dimensional GC, you only see a few things. You might see a cluster of things, but in the 2D, you're going to see more things in it. So with the separation, we are able to see more of the compounds. And with tires, which we're looking at, which has a lot of those compounds, which might co-elute in the 1D, in the 2D, we tend to separate them very well. And we use a flow modulator for this, and we also use a tough mass spec for this as well. And the system which we use in this is we use a pyrolysis method for it. And the method is really so good because we've gone through a lot of process in making sure the method is suited for the test we are doing. So we developed the method, and in support with Antis Consulting and with NPL, we were able to validate our method, evaluate it, and quantify the compounds we see in it, because we've run a whole lot of tire samples, as you're going to see in the next coming slides, to kind of see the background, what are these compounds in tires. And like Nick said at the beginning, there's 6 ppd in all of the tires. All of the tires tend to have 6 ppd, which is really a key thing here in tires, which is the key thing in our discussion today. And we've been able to do this, reproduce it, repeat it again and again. We are still seeing those compounds in tires. And we also had to do an interlaboratory comparison with a few other labs to see, with the method we've developed, can they apply this method and see the same thing we are seeing. And we did that, and that was really good, and we came back with a very positive result for us as well. And the test program which we run on these so far, we've run nearly 500 plus tires, new tires, within the US and Europe. So we've run a wide range of different kinds of tires, sourced in different areas, different places, just to see what's really in tires. And we tend to take the tread block, of the tire, and then try to see what's really in the tires. And then we do what we call untargeted analysis on it using pyrolysis. So we pyrolyze the tire, we tend to see what's the whole compound that I need. So we see the full organic compound, identify them, and we are able to quantify them based on what is being released off the tires. And we do this. What enables us to do this is this system which I talked about at the beginning, the two-dimensional GC, because it's able to separate. It's able to separate. So by the time the compound goes into the first dimension, it's separated on the first dimension using the flow modulator. It then goes into the second dimension, and in the second dimension is a different polarity of column, such that in the first dimension, if compounds were not easily separated, in the second dimension, it will separate those compounds out really well. And why is this really important? Why is it key? They may co-elute. There are so many compounds. There are so many compounds. In a typical one tire we run, we see nearly an average of 410 organic compounds in one tire. So if you're seeing 410 organic compounds in one tire, in average, that's for you to separate that out in a 1D, all of them will coalute. That's why we needed a 2D GZ. And we're able to separate all those mixtures and then group them. We could be able to then put them in different kinds of groups. Once we separate them, we identify them through the tough mass spec, which has a library, which we're able to search those compounds and say, is it really this compound? And why is that? Why is that important? Why do we have to? Because there are compounds that you may find and it's kind of say, oh, is this really this compound? But with these, we are able to use this, search this, and also we do our internal identification of those compounds. And so far, in total, we have nearly 16,000 compounds that are in tires, different compounds that are in tires, which is really, really key, because how do you match all those out? So we've taken our time out and then group them into different functional groups to see, oh, where do they fall in? Where do all those compounds fall in? And with needs, which is really a good thing for us as a good start, we're able to identify them first there, and then we take our time to go through them individually to see what are these compounds. What are they? Are they really what we've identified? Are they linked to tires as well? And then with the identification, once we identify them, we have now to quantify. And so far, we're able to get approximately 75 individual standards to be able to quantify the compounds that we have identified in tires, and which is really key, because you may find them, they may say, oh, what are the concentrations are they? Oh, what have you found in them? Are they high? Are they low? So with the quantification, we're able to see, okay, which are the tires that has high concentrations of these compounds we are seeing in them. And there are some of them which we don't have standards, but we do a semi-quantification of the other ones so far. But we're still building on quantifying all of them with correct standards, with the proper standards for them. And it's going by what we see, going by the whole lot of compounds we see. The question we ask, like, this is a very complex mixture that you are seeing in tires. It's really, really complex. So such that you'll find things that break down, there are breakdown product, there are things that might be reacting. But with the method we have developed, we are able to resolve some of those complexities, because the method is so swift that you don't have to worry about those breakdown products overshadowing the whole compound list. So we're able to sweep out the compounds down to the column quite quickly, such that we're able to see what we really see, what is really in those tires, and also what we then go forward to do and look at what are the potential toxicity of this compound, because that's the key thing. The key thing about 6-PPD, which we're talking about, is what it kills fish. It kills fish. So it was toxic to the fish. That was what caused the whole story about everybody's looking at why did 6-PPD kill fish. So we're looking at the toxicities of all of these compounds. How toxic are they when they are being released into the environment? And which is a really, really key thing. This is a very complex thing about tires, because with tires, there's a lot of mixtures, a whole lot of compounds being mixed here and there to make the whole tire. So by the time when they then break down, what do you see? Complex mixtures of different compounds. And for us to kind of understand this is an example we're giving here, just to show you a typical thing. So a typical thing, you say, oh, you see benzene in tire, you see toluenes in tire. How are they formed? How are they formed? A simple one would be, it may be formed from styrene butadiene rubber, which is that thing, the styrene there we're seeing there, which if once that breaks, once the attached group they break off, we can see benzene. When this group breaks off, we could still see toluene. So this is a little of the complexity of what we see. So talk less when you go to all the bigger compounds. Talk about 6-PPD. It might be breaking down to give you all sort of other things. So we have to kind of understand what are the compounds that we are seeing. Are they really linked to tire? Because you might see compounds in them that are saying, oh, they are breaking down, but you say, oh, this is being identified, but might not be related to tire. So those are the kind of complexity things we're seeing, and which is really key, to us. I'll hand over to Nick now.
Great. Thanks, Ime. And I think that's a really good example of how complex tires are and the lengths that we're going to try and resolve what we see through our pyrolytic process to figure out what's in the original tire themselves, because that's then the key to understanding the environmental and health impact. I put this one slide up. We do also cover metals. We focused on organics today and 6ppd, but we do also have a method for looking at metals, and we've published information on that as well from Tyres, and are happy to talk about that further with any of you and at a later date. But I don't want to dwell on that further because I want to move on with the time we've got left to what's the data, what's the results of the data over those 501 tyres, what's it telling us, and some insights into 6ppd. Well, the first one, so having tested roughly the same number of tyres in US and Europe, we can see that US tyres on average contain less 6ppd than in Europe, as shown in that table. For car tyres, that is, for light duty. For light duty, it's about half the amount that is in European tyres. But interestingly, for heavy duty vehicles, heavy duty tyres, it is about the same. And for medium duty sort of truck van tyres, it's somewhere in the middle. So that's a very strong high level trend. Then we can also segment the tyres by different types. Just to get an idea of whether there is a big variation in 6ppd, to what extent, in a sense, it is a design choice. So if we segment very simply by the budget, mid-market and premium tyre, so in crude terms, the cost of the tyre, what we find in Europe is that the budget and mid-market tyres have more 6ppd in them than the premium tyres, which are about 53% lower. But by putting the box and whisker plots here, we can see that even within each of those categories, there is a wide variation, and that is largely, and that is true across all the different manufacturers. There's variation within each of the manufacturers' ranges. But if we look at the same question within the United States, we find exactly the opposite pattern. And in fact, premium tyres have 67% higher 6ppd concentration than budget tyres. But again, you can see very wide variation. So there are some systematic trends by market segment and price, but also very significant variability within those. Another way of looking at it, and this is pertinent to the trend towards bigger and heavier vehicles. What's the correlation between 6ppd and the diameter of the tyre? And we see quite a significant variability in that, and this is the rim size in inches. So we see in the United States there is a significantly increasing trend of more concentration of 6ppd the larger the wheel becomes, to the extent of 20-inch tyres have roughly 5 times the concentration of 6ppd than the average 14-inch tyre. We did also run the same analysis with tyre width, and the similar correlation was not seen. Europe has similar trend, although not as strong. Still, again, we can see big variability within the categories, but in this case, 20-inch tyres only have concentration about 88% higher than 14-inch tyres. And again, the same trend was not seen on tyre width. We can segment our data by manufacturer as well, because we're trying to understand, what are the things that determine, are there some external characteristics that determine or can help us predict the level of 6ppd, or is it very simply a manufacturer design choice on a tyre by tyre basis? So here, if we look at all the US tyres, and to be clear here, this is the tyres sold into the US market, but can be manufactured by any company around the world. So in this case, Yokohama stands out. Of the ones we've tested multiple tyres, and we have a box and whisker part of the chart, Yokohama's 6ppd concentration on average is 79% below the average for the whole group, whereas Arroyo tyres are double the average. But as you can see, again, within each manufacturer, there is quite significant compound variation. So that does start to suggest that it is a product level choice, even within a manufacturer, as to the level of 6 ppd. I mean, we do also have to caveat this to say, even though we have tested a lot of tyres, there could be there possibly some residual selection biases in the tyres we've actually been able to test. The EU, we've tested more manufacturers selling into the European market, primarily as there are more budget Asian brands on sale in Europe. But again, Yokohama comes out towards the low end in Europe as well. Most of the established European and US owned manufacturers are clustering in the 1500 to 2500 nanogram per milligram range. And to be clear, what that means is nanograms of 6 ppd per milligram of tyre material tested. What I would conclude from this is that it does appear to be a product level decision that is going on. And what it does mean is that Europe's approach to applying some sort of limit value may be a good approach, in that there are some very good ones, some very low concentration, but other very high. And if only we can eliminate the very highest concentrations, we could bring about a significant reduction in total 6 ppd release without having to ban 6 ppd. Moving on then specifically to look at alternatives to 6 ppd. Well, as I mentioned earlier, 6 ppd is in all the tyres we have tested, but we've also identified 18 other preservatives, as you can see in the chart, only 4 of which are present in a majority of the tyres we've tested. So there are 4 others that are quite commonly used. But the average concentrations are low, and at 0.05 micrograms per milligram of tyre on average. So there are a number of others that have been identified through the Californian process that we are not seeing. So 7 ppd, CCPD, plus a range of other non-PPDs. There are also some other compounds that the USTMA's consortium has identified that are not in their process but may be revisited at another time, including 8 ppd, but equally those are not being seen as yet either. But we are seeing therefore the use of some alternatives, but in relatively low concentrations and often not in a wide range of tyres on the market. Another way we can look at it, we can look at the total concentration of 6 ppd and its alternatives by individual tyre. And here I've pulled out the top 5 tyres with the highest concentration of 6 ppd and its alternatives. And what's interesting is that they are all winter tyres. And so we can see, for example, I pulled out the details there of the Michelin Alpine 6 tyre, where you can see the exact detail, and we're able through our method to see the exact concentrations of those various preservative compounds. If I had to characterize it in a colloquial way, that we are seeing manufacturers experimenting with 6 ppd substitution rather than a wholesale transition to any alternatives. Finally, another way it's useful to recap on the differences between US and European tyres. If we focus on these 5 preservatives that we're seeing, you can see from the lower table the relative prevalence, by meaning whether they're present or not, and the relative concentration between US and Europe. Where 1 would mean that US and Europe are the same, and below 1 means it's lower in the US. So what you can see is, in case of all 5 of those preservatives, the concentrations are lower in US sold tyres. So finally, just to think at the sort of wider pollutants, so what other potential pollutants are we seeing that are either in the tyres themselves or potentially formed through degradation in the environment? Well, as Ime said, we're about 16,000 chemicals we've seen. Well, in fact, it's 15,000 916 unique compounds so far identified. And there are 6 notable compounds that we're focusing on further because of their potential chronic effects and in some cases cancer risks, as you can see from aniline down to phenol and styrene, many of which are used as intermediates in the production process. This is not an exhaustive list, but these are ones that we've chosen, selected on the basis of their potential hazard and also their prevalence in the tyres. We assess that hazard by essentially coming up with a weighted toxicity factor using the hazard code submitted to the European Chemicals Agency. I don't plan to go through that in detail today, and that's something we can discuss offline, but it is a good first pass way of assessing the potential toxicity of these compounds. As we can see here, if we apply that method to 6-ppd and I've chosen IPPD as one alternative, and then these other compounds we're identifying, you can see often that these have potential toxicity of more than double 6-ppds. So I put this up, the message being we should make sure that although there's a pressing need to understand 6-ppd and mitigate it, we shouldn't conflate total tyre toxicity with just 6-ppd concentration. There are a lot of other compounds in there that we should be mindful of. And here again, I can put up the concentration between of these other compounds of concern between US and European tyres. And while 4 out of the 6 of them are lower and substantially lower in US tyres, there are 2, including phenol, that are higher in higher in US tyres. So it's a mixed pattern, which speaks to the design of US tyres is very deliberate and different for that market. So that's the data I wanted to share today. And as I said, we'd be very keen to discuss and take your questions and work with you. In terms of further insights on what we can also offer, many of you, I think, are already followers of our Tyre Emissions Research Consortium, which is a free access repository of the latest academic research on this topic that we curate. We also have all the data we've talked about this morning is available on a subscription basis through our Tyre chemical fingerprinting database, where you can search down to the individual level of individual compounds and individual tyres for any analysis that you might want to do. If you want a higher level digest of these issues and tyre emissions in the wider sense, we publish a subscription quarterly report called Tyre Insights, which we're now working on the 3rd issue of, which will come out in a few months' time. But that's really good if you need a quick but authoritative summary of what's going on. That's a good place to start. And finally, it'd be great to meet. We run a series of conferences on tyre emissions. We started this year running one in Prague in February and in California in April, and they went very well. We had really good feedback from it, and so we're going to be running them again next year, again in Prague in February and then again in California. So please do, if anyone has any of their latest research that they would like to present, please let us know. We still have a few slots in the program, but please do sign up to attend if you can, and we can progress discussions there. So on that note, thank you very much. And that leaves us about 20 minutes for any questions. But thank you very much for listening. Thanks, Ime, for your contribution. So I'm going to pause for a second and review what questions we've got in the chat, but please do to keep them coming. And if you would like to see the presentation afterwards, please do send me an email, and any other questions we can correspond afterwards. So thank you very much for listening. Bear with me for a few seconds, and then we can take questions. Thank you very much. So yes, Ime and I are now available to take questions live. and I'll dive straight in if I may, but please do keep them coming in the chat box. The first question we've got is a question about how the 6 ppd level in tyres has been determined, whether it's from wear particles and analysing those, or whether it was from new tyres and cutting pieces of tread compound of the unworn tyre. Well, what you've seen today, that is all based upon cutting pieces of tread. So it's what's in the original tyre. And moreover, it is tyres when they are brand new and unused. So typically a few months from between original manufacture and when we've been able to sample from retail or wholesale, but crucially before the tyres have actually been used. That doesn't mean that this method cannot also be applied to testing wear particles. Obviously, by that stage, some further chemical processes will have gone on in the environment, but nevertheless, the method still does apply, but that's not the data shown today. Next question, have we received any explanation from manufacturers about the large differences in 6 ppd between these different segments? I guess the short answer is no, we haven't. I mean, they have seen much of this data. I mean, not least the US version of this data was presented, or some of it was presented first at our conference in California in May. But there's been no official reaction from it. To what extent the industry is aware of that degree of variation between different manufacturers, I couldn't even say that for certain. And hopefully at some point we will get some explanation. In a sense, because it is a really important piece of information, because essentially in crude terms, if some people can get 6 ppd concentrations down very low, why can't everyone else? Is it something actually to do with the profile, the mix products in a manufacturer's portfolio, say skewing more towards snow tyres? But there's definitely an important question there to answer. Moving on, where can we find more information on the evaluation of 6 ppd alternatives? Well, the best resource there is the Department for Toxic Substances Control website, which is running the alternatives analysis process. Although the US Tyre Manufacturers Association is pretty good in terms of posting updates on its own website. It's important to note that while that covers a lot of the market share in the US market, is not everything, and there are other manufacturers not a party to that consortium, which typically, as far as I can see, publish less information. But DTSC is probably the best place to start. Very simple question, why didn't we use any used tyres? We may well do that in the future. There is no reason in the method why it doesn't apply to that. The reason we haven't is, in essence, that by taking the tyres new, we take out the variability of how a tyre has been exposed to the environment, how it has been used, because we're trying to do an inter-model of tyre comparison. It's also the closest thing to understanding the decision-making and the manufacturing process that the manufacturer is going through. I mean, the product as it is created new and sold to the end consumer, and how it then consumer choice between a variety of tyres actually then impacts upon the environment. But there may well be longitudinal studies that we do to look at and test the same tyre through time as it ages, to look at how the chemical profile differs over time. So watch this space. And if there's any specific experiments you're interested in us running, I'm all ears. Next question from Kelly. Have you compared US OE tyres to tyres sold in the EU? In the US, OE tyres tend to be manufactured to have lower rolling resistance, which might be more like EU replacement tyres, which are labelled for their fuel efficiency. Now, that's an interesting aspect on it. And it's certainly true. And you say that US tyres are manufactured at low rolling resistance. I mean, European tyres are also very much engineered for that, because that's a crucial part of the vehicle manufacturers delivering CO2 reductions. However, European tyres also have great pressure on the grip and sort of winter weather performance, and to some extent, braking distance, and to some extent noise as well. So in a sense, there are more pressures, in my opinion, on European tyres. And that is a possible explanation why the chemical compositions of European tyres seem to be more complex. So they are trying to juggle more tougher competing constraints. While US tyres, I think it's a question of rolling resistance of fuel economy, but also longevity and cost. And so that, in a sense, that does come out in the comparing of our US to our tyres sold in the US to tyres sold in the EU. That does seem to be borne out by the data we're seeing. Although I have to confess, these are intelligent hypotheses that seem to align to the data. It's not something we've yet been able to validate by any statements from the manufacturers themselves. Okay, next question. Regarding the 6ppd alternatives listed on slide 32 as may be revisited, have those previously been disregarded, and if so, why? My understanding, and conscious others on this call may well know better than me, is that they have been, in a sense, set aside due to a limited amount of information available on their potential toxicity. And by that I read is it would be impossible to assess them properly within the alternatives analysis through lack of scientific information being available, and they may be revisited if sufficient information became available at a latter stage. So hopefully that's at least true to some extent, but Kelly, feel free to correct me if that's wrong in any way. A question here: how far back does our data go? To what year of tyre? And have you noticed any trends in your current and historic tyres? Now, that's something that we're not quite yet at the stage of being able to do. Our collection dates back roughly three and a bit years at the moment, since we've really started this program in earnest. Because at that point it was very difficult to get earlier model year tyres that were still in a completely brand new condition. So we're really now got a trend of about 3 years, and that's obviously growing. Currently, it doesn't elicit any useful trends at the aggregated level, say at the budget, mid-market, premium segmentations we've talked about. At the moment, we are looking at sort of spotting the changes in the use of particular chemicals, not least 6ppd and its alternatives, and seeing what new chemicals are appearing, the concentrations of alternatives to 6ppd, how that's changing. So we're beginning to get a little bit of insight. I wouldn't say there's any strong trend beyond saying there's clearly a growing experimentation with more alternatives to 6ppd and gradually increasing concentrations. But I just feel we don't have quite enough sample size or time scale yet to be any more definitive than that. Question here: for your on-road tyre sampling system, did you examine sampling line losses? If so, were they significant, and do you apply any correction factors? Yes, we have, and they are non-zero. They do warrant correction factors. What it is, it's important to do correction factors for different size categories because the loss rates are different. So yes, that part, but there is also the other part of the sampling system, which we've been doing a lot of work on, which is trying to improve the collection efficiency in the first place. We've been doing a lot of computational fluid dynamics around the tyre and the wheel arch itself and the placement of the sampling probe, and indeed the design of the sampling probe, to try and maximize the collection efficiency. We are finding, for example, that a lot of the very finest particles are collecting in the wheel arch in a relatively stationary zone, whereas the bigger particles tend to shoot out backwards and fall fairly rapidly to the ground. Also, more particles spray outwards, both outside and to the left and right of the tyre, than we were perhaps expecting when we started. So in a sense, we're trying to take a holistic view of the system to try and capture as much as possible and then correct for the respective sampling losses. Next question. As you mentioned, selection bias can play a role in the differences in 6 ppd concentrations, for example, in company comparison. Did you have an equal numbers of premium versus budget tyres or light use tyres versus heavy truck tyres? The answer is it's not even as simple as quoting by numbers in those categories, because there are so many subcategories as well. What we've gone for is the maximum number overall and the broadest possible sampling across different manufacturers, across different usage cases, and then trying to look whether there are any artifacts in our selection. So are we overrepresented by a certain manufacturer in a certain category? So I've tried in doing that only to put forward data today that avoids any of those obvious sampling biases. And we haven't yet, and this is very much work in progress. We are very keen to make sure we are not creating any, seeing any false trends. But that is been our approach to date, just to go for maximum sample size with broadest possible spread. Next question. You noted a wide variability in concentrations of 6 ppd. Were there statistically significant differences between these categories? Well, in a sense, the previous answer gives a clue to my answer. Yeah, I can do statistical significance tests between our data, and indeed some of them, for example, for the US tyres and the higher level of 6 ppd, the European tyres with the higher level of 6 ppd in them, they do. There are some statistically significant ones. However, I remain concerned about certain biases. Also, you can see from the box and whisker plots that a lot of them aren't statistically significant. But actually, there are nevertheless useful patterns to see when I drill down into those and see the pattern by manufacturer or the pattern by rim size. There are actually useful insights, even if they are short of statistical significance. So I think this is ongoing work in terms of getting as many more samples as we possibly can to understand effectively the decision-making processes which are guiding manufacturers, and then essentially what I want to be able to do is ask better questions, to ask better hypotheses, and then hopefully I will get to some more statistically significant patterns. And it would be great to get more input from the industry to help me ask the right questions. Whether I will get that or not, time will tell. But as you can see there, it's there aren't any very simple statistically significant conclusions which would give us an answer to this whole picture. It is really very complex and multidimensional. Okay, moving on. Kelly, thank you very much for that comment. I did get that previous answer right. Appreciate that. That's great. Also, picking up Duncan on the CFD question. Yes, this is this is a perennial, this is a really fundamental problem actually for real world tyre emission sampling. The complexity of what we've seen with our CFD, which is, for example, highly dependent on vehicle speed as well. So what is gathering where is really quite sensitive to speed, leads me to view that perhaps longer term we will need to bring the sampling of tyre emissions into the laboratory, which will also at the same stage have the benefit of being able to separate the tyre emissions much more rigidly from the road wear, resuspension, brake wear, which would have a benefit. It's not as straightforward as doing that for two main reasons. One is no lab-based method that I've seen so far, and I've talked to many, is getting, in my view, even close to being able to replicate the size distribution of particles, the morphology of particles, such that the lab reflects what happens in the real world. And secondly, there would need to be a very careful validation of any laboratory techniques against the real world to avoid an analogous situation to what happened with tailpipe emissions, which was we had an NEDC, New European Driving Site, in the laboratory, which was beautifully repeatable and everything, but just drifted further and further and further away from reality. And in that gap, Dieselgate happened. And so we've got to be really careful. We're mindful of the lessons of the past and making sure everything ultimately reflects real world behavior. But I do think to solve this problem, to get maximum collection efficiency and a separation of the tyre particles from everything else, we may indeed in the end have to end up in a laboratory. So we will see. Maybe there will be some breakthrough in terms of on-road sampling, and we're certainly working on it and trying, but it is a complex problem. Okay, I think I've covered most of the questions. We do have a couple of minutes left more if anyone has got a final question, but if not, as you can tell, we are very committed to this topic, and IME is, as you can tell, has been passionately committed to getting the most sort of sensitive and sensitive process, and one that can identify and quantify the most number of compounds. So this is all very much work in progress. We will have future webinars on this topic. I do encourage you all to come to our conferences. So it's 30th of April to the 1st of May in California. Very nice time of year to come to California if you're based elsewhere. So please do come and join us. And we genuinely want interaction. I mean, we really want to get to the bottom of this important and pressing environmental challenge, ultimately to ensure that motoring can carry on in an environmentally consistent and sustainable way. So on that note, I think I will wrap up. Please do drop us a note if you have any questions for me or MA. We'd be very pleased to hear from you. And thanks for your time. Appreciate everyone's busy. Have a good rest of the day, and hope to speak to you all soon. Thank you very much.